Alright, so I just want to take a quick look at what you had for homework, because there are times they will ask you to factorize this, right? We started to look at factorizing a squared minus b squared, and we got a minus b by a plus b, right? So what that means is that a minus b is a factor of this, a plus b is a factor of this. That's okay? Remember that? And the homework was what? A cubed minus b cubed? Yeah? Okay. So let's see. Right. So our homework was to factorize a cube minus b cube. Why? You're not seeing that, Aria? So you're not seeing that?
No.
Right. So since what would be a factor of a cube minus b cube? What is guaranteed to be a factor? A minus b. How we could check it and make sure? No, before long division. How you can check and see if a minus b is actually a factor? Right? Here what you can do. If f of x is equal to a cube minus b cube, what you can do is you can check and see what is f of b. Right? Let's make it a little more specific. Let's call this e. Right? Check what's f of b. F of b will be b cube minus b cube, which is 0. So it should work out. Right? Remember this rule? If you divide f of x by ax plus b, you should get what? You should get the remainder, right? And if the remainder is 0, then it's a factor. So you could also use this here, right? Anyway, let's jump straight into it. A cube minus b cube. So let's see if we could factorize a cube minus b cube. A into a cube is what? A squared. A squared, nice. A squared by a is a cube. A squared by, remember, a squared by a is a cube. A squared by minus b is minus a squared b. Next step, subtract, subtract. A cube minus a cube is 0, right? There is no a squared minus b term, right? So therefore, there's a 0 on top. So it will be minus minus a squared plus b squared. That will give you plus a squared b. And then you bring down your minus b cube. Any questions, sir? Shivish, any questions? You sure? What's the next step, Shivish? A into a squared b. And the answer is what? A, what, Shivish? That's 2 in a row, you know. A by b is a squared b, and ab by minus b is minus a b squared. Okay with that? What's the next step? Minus sign, minus sign. A squared minus b squared, that'll be 0. Then you have a minus here and a minus here, so that'll give you, that will give you plus a b squared, and then you bring down here minus b cubed. What's the next step? What's the next step? Go again. Go again. A into a squared b is what? Sorry, a into a b squared. The a's will cancel and you'll get b squared. Then multiply it back. B squared by a is ab squared. B squared by minus b is minus b cubed. Minus minus. Right? So you're good to go. So therefore, if I ask you to factorize a cube minus b cube, the answer is a minus b by this on top there. By a squared plus ab plus b squared. Okay? I'll carry on the board today because the camera not working, right? They'll fix it today. So next week I'll go back on the board. I know it's easier to follow sometimes on the board. right? So if I ask you to factorize a cubed minus b cubed, that's what you'll get. Any questions online there? Oh, some people did it homework, right? Oh, good job, Tanisha. See that Shivi? People do the homework. That's how you did the homework? What's the next one? What's the next one? Oh, plus, I gave it plus as well. Right? How you would factorize if they ask you a to the 5 minus b to the 5? How you would factorize a to the 5 minus b to the 5? What will be a factor? Start with that. A minus b, right? And then long divide. Okay? A minus b will be a factor. And yeah, then work it out. Right? What's a factor of a cubed plus b cubed? A plus b. Right? So for those who didn't get a chance to do the homework, long divide for me a plus b by enter a plus b enter a cubed plus b cubed. Try this here, please. Right? Oh, wait, this is my phone moderator. Oh, sorry, Stacey. Right, we done? So once somebody it's a long divide on next week, right? I know we now start. You want next week off? Yeah. Next week is a holiday now. But we can no, I can do it online early with them. I use the phone. I guess it was on there too. But we're not saying whole day. How come many even? For real? I know why it's the good. I don't want to get him a day off. I don't want to get you wrong idea about lessons. Yeah. Huh? Yeah. Right. Long divide is. Oh yeah, she had messaged me since 2 o'clock. Oh yeah, let's long divide. Come on, looks just a pretty finish already. Ready? Nicola, you can do this. Can divide. All right, so let's go, right? A into a cube is a squared by a is A cube, A squared by E is A squared B. Minus, minus, this will be 0. You'll be left with minus A squared B, and then you bring down the B cube. So again, A into minus A squared B is minus AB. Minus AB by A is minus A squared B. Minus AB by plus B is minus AB squared, right? Subtract, subtract. This will be 0. This will be plus AB squared. Then they bring down the M cube. Long divide again. A into AB squared. That will be B squared. B squared by A. B squared by positive B is subtract, and you get 0. So therefore, A cube plus B cube is equal to, of course, you can learn this expansion of it. You don't have to go on long divide all the time, right? A plus B by A squared minus AB plus B squared. What is different about the expansion? The signs, right? The sign in front of the AB. Okay, copy it down. Adam, are you okay there? Ishmael? All right, so let us all right, so head up logic and reasoning. I will send you this handout. Actually, before we leave here, I want to add everybody to the group one time. Huh? It's taken too long to do this. Huh? No. Starting this week. All right, let us hope this note's good. I wonder if I could find back my next copy, boy. All right, and I hope this note's good here. Right, who needs to be added? Right, all those who online and you need to be added, send me this WhatsApp. Yeah, what to add everybody. Have a good day. All right, so I need a little favor, right? All the people online, send me a WhatsApp. Hold on here. Hold on, eh? Just 1 second, yeah? I want to add everybody because it's taking too long to add people. Right, I want to send you some of the notes. Right, so for those who knew, message me please 723-0529. Right, message me on WhatsApp and I want to add you now. I'll just spend 2 minutes doing that, right? Message with your name as well. So, yeah. No killing. Anything else, killing? Okay. Antonio, when you're upstairs, you feel it hot. When you're downstairs, you feel it cold. Make up your mind now, boy. I come downstairs, so you'll feel cold. Anybody here need to be added, just send me a WhatsApp, right? With your name, I will save it one time and I'll add.
Sir, I have a question.
Yeah?
You could write your match as a private candidate.
Yeah.
Okay.
Yeah. Hello? Right. Who else we had to add? Adam, Nikolai. I don't have your number saved, Nikolai. Devish. Amelia. We have so much Amelia's. Amelia, what was the last name again? Oh, it's you? Oh, okay. Sahadio. Right, I need to be added, but you didn't give me your name or Timothy. Israel, I went to add you now. Ishmael, I mean. Stacey-Ann. Emily, you in the group already?
Yes, sir.
Okay, good. What's your Sadi, what was Amelia? Amelia, it's a attend bite, yeah? Yeah. Check it and see. Oh, I didn't add Samira. Right, anybody missing? Everybody in the group? Anybody? Did I miss anybody out? Adia? Yeah, I did. Shamaka messenger. I think I just had Vika. I did not you. I did not you read that to Nikolai? Which Nicola? Oh, the one kind of weird, right? I'm sure which one is that. Right, let me see. I'll get you this. Antonio, you want to? Next group you want to go in? Yes. Right. Anybody missing? Anybody on any group now? Who missing? Somehow what's up again there? Or Divish? Yeah. I thought I just probably don't want to argue. I know it didn't come out. When I clean it up, I'll move them out. I'll clean it up just now. All right. So I'll send back this note here. You all do have to write. Okay, are you ready?
So this class is going to be recorded and
yeah, everything recorded and you know together. Place too cool, place too hot, or they can make up a little. Huh? No. All right, so let's go. All right. So everybody have that handout now, right? So we're going to take a look at logic and reasoning. In logic and reasoning, no more numbers, just letters, right? Those who did physics and remember logic gates is very, very similar. Okay? So let's start here. In logic and reasoning, we need to understand those three things there. Right? We're trying to get to right. What's a proposition? A proposition is basically a statement that can be true or false. Okay? Right? So example, the place is sunny. That's a proposition that can either be true or false. Okay? A truth value, again, similar, can be true or false. A truth table is a combination of all the truth values, right? So if you look here, watch here. If you have one proposition, that proposition can either be true or false. That's all, nothing else. Like binary, can either be high or low, true or false. If you have two propositions, then you have four possible combinations. So you could have both statements being true, one being true, the next being false, and you could have one being false, one being true, or both being false. Okay? What would happen if you have three propositions, P, Q, and R? How many possible combinations you could have? Look at the formula.
2 to the power 3.
What's that?
2 to the power 3.
Nice. So you'll have 2 to the power 3, 8 combinations. Okay? How do you figure it out? Instead of doing it right? The trick is just doing this. 4 trues, 4 false. 2 trues, 2 false. 1 true, 1 false. Right? If you do that properly, it will line up and give you your 8 possible combinations. Okay? So if you have 1 proposition, you have 2 options. If you have 2 propositions, you have 4 options. If you have 3 propositions, you have 8 options. That's okay? Nikolai, you're watching, right? Oh. Are you logging? Oh, okay. So the first, right? Hold on. Right. So the first thing that we need to know is something called negation. What does negation mean, right? Those who remember those physics, negation was a NOT gate, right? So if I tell you that P is true or false, right? Then the negation of P will be false and true. Okay? So the negation of false is true and the negation of true is false. Just the opposite. So this here is a symbol. Are you okay with that? So suppose I give you a statement. The statement is P, Bob is smart. Then what would be the negation of P? Bob is not smart. That's okay? We have to learn to use the worded form and the symbol form. Are you okay with that? Nice, good. What will happen? Well, I cannot show you the answer there, right? But what will happen if you take a negation and you negate it again? It will cancel off. Nice, good job. Wait, I thought Amanda was here last week. No, physics, she was here. So the double negation is P. Right, those who online, just do me a favor now. When you're messaging, do message the host. Message me. You want to talk here. Right. I'm not feeling cool. No. Right. So the double negation is P. So if I told you that P is T, we could set up a truth table for this. Huh? So P could be true or false. Negation of P will be false and true. And the double negation is what? True and false. Right? So basically, this giving it back this. That's okay? Double negation giving it back the original. So it's like when they connect two NOT gates, they're canceling out. All right, nice. So here is the first technique that we're going to learn to prove logically equivalent. So if I ask you, Brittany, show that P and negation, double negation of P are logically equivalent, what you will do is you'll set up a truth table. Okay? And if this column is identical to this column, then they are logically equivalent. That's okay? That's the table method. There's a table method and there's the algebra method. The good thing is the algebra method never came, but we still have to learn it. I'll show you that a little later on. Everybody okay there? You're okay with negation? Online? Are you okay there? Adam? Emily?
Yes, sir.
Yes, sir.
All right. Okay, and you're talking too. Nice. Right, compound statements. We need to learn about compound statements, right? Compound statement is where you put two simple statements together using some form of connection. Okay? The first connection that we're going to learn is conjunction. Okay? Once you see this upside down V, that's conjunction. If you see an upside down V, that is what? Disjunction. Oh. Okay? All right? So if the V upside down is conjunction, if it's not, it's disjunction. Conjunction means and. Okay? And what's the truth table for it? A true and a true gives you a true. Everything else is false. And that's what I want to learn. I want you to learn that this symbol conjunction, right? False always gives you a false. Remember that, right? Once you have a false, you always get a false. Right? For those who want to write, you can make a quick note of that. Right? Although I give you the document, some of you will learn better by writing. Make little notes. Okay? So you have to always keep going back to the handout. Some things I'll give you a handout, for some things I'll give you the thing and practice it, right? What you want to do is practice a lot. Right, so make a note of what is conjunction. What did I do? Hey, I guess the. All right. Right, so that's conjunction. Right, conjunction is whenever you have two truths, you'll get a true. Right, if you have a false, you guarantee to get a false. Are you okay with that? Let's practice our first truth table right here. Right? So all these examples, not in your book, so you could write it down. Huh? Come on. What did I do, boy? Huh? Have to go back and sit. Oh. Should we try it? Should we try it? What did I do here? Oh, what do I? Yeah. I tell you too. Right. Let us develop a truth table. Let's do a truth table for negation of P and Q. All right. So we're going to do a truth table for that. How many variables you'll see in there? All right, P and Q. And then how do we reach the P negation P and Q? So in order for us to set up this truth table, we need to get not P, and then we apply the conjunction, right? So we need not P, and we need not P and Q. So here is true, here is true. All right, nice. So what is the negation of P? Help me out, please, Nikolai. FF, PT, nice. And now, what is the negation of P and Q, Shivish? Yeah, this here, negation of P and Q. Help me fill out the truth table. How you get that? So you're looking at what? You're looking here and here. So false and true is what? What is false and true, Shivish? False. What is false and false? What is true and true? true and false. That's okay? Okay, so that's the way you build a truth table. Look at how many variables you have, set up the inputs and then work out the outputs.
So what sign is that? Not the not part. Not the negation part. That's a
The symbol,
yeah.
that's the same symbol here, conjunction.
Okay.
How come on here still? When we apply my Saturn, what time pass? Right, as a quick practice, Bill, right, as a quick practice, try this, please. Huh? 2NY. Try and build this, please. Negation of P and the negation of Q. So that, please, a quick practice. Hurry up, try to build up that, please. Anybody confused online? You have to charge the iPad.
So I'm kind of confused on how you're getting the not P and Q.
What's that? So you're doing the same. So you're doing something similar. So you have P, Q. You have to find negation of P, find negation of Q, and then conjunction them together. So you try to fill this truth table out. Is it logically equivalent to anything earlier? Is this logically equivalent to anything it is so far? No? All right, let's see. Just do all this truth table fast enough, Aiden. First column. This one, huh? Next one. This one here. FT, FT. Right? Remember, it's the negation of this, right? And what's the last thing? F, 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 T. Nice. Okay, good. Yeah. No, I don't have to, but I general order. Why you don't have to be like that. All okay in the back? Yeah? Quiet, boy. All again, right? So what to do next week? No class? We can do it. Huh? All right, any questions online there? So you gotta learn to work with the truth tables, right? All right, let's go. Adam, you okay, right?
Yes, sir.
Right. Okay. Watch this here, earlier. See, this make any sense here, Sarah? Watch this part of this statement here. Brittany, hello, watch here. Right? Here's what they're saying. They're saying P and false always giving you something false. That make any sense? P and false always giving you something false. That making sense? Remember I told you all, once you have false and conjunction, it will always be false, right? That's all they're saying. P could be anything. You know, log in there. Right?
So
P could be.
so what you have, once you have a conjunction and a F is always false.
Yes, yes. As a rule you have to learn. He didn't know reach here. So class almost done. Yeah. If what? All right, nice. Let's continue here. Right, that was something that we did a little while ago. We'll come back and do some more truth table just now. Right. There are two definitions that we need to learn. There are two definitions we need to learn. If something is all false, then the statement is said to be a contradiction. Right? If the statements are all true, it's said to be a tautology. Okay? All true, tautology. All false, contradiction. If all the values are true, right? All the truth values are true, then this statement here is a tautology. If all the values are false, then this statement here is a contradiction. Yeah? Next one to learn, disjunction. Make a note of it, please. Disjunction, the symbol is the B, and it's like an OR gate. It's like an OR gate. So once you have a true, you're getting a true. Two false giving you a false. Hey, right, quickly right now on this. We got some questions just now or no? Right, down. Just the summary. Just remember the summary. Right? This here is the summary. You want to go upstairs and eat? Yeah, but I think you don't have to. Huh? That's further summaries. So based on what P is, that will tell you what the answer is. So see this here? If P is true, then true or true given it true. So it means that whatever P is, that's the answer. False or false given you false. All these are rules you have to learn in algebra. But it's showing you what are they kind of show you where it came from. Sometimes it's easier to remember this than all the rules. Okay? I'll show you how to use the rules later on. Right? So that is your disjunction. Yeah, that's just a conjunction. So you have to look at this symbol here. You have to look at this symbol. Okay? So that's disjunction. Let us try one. Huh? Let's try that then. How many variables you have there? P, Q, and R. Do that, please. Huh? No, you wouldn't have 6, you would have 8. Yeah. So P and the Q, or Q or R. So I want you to set up this truth table, P, Q, R, and then set it up for now. Try that, please. P and Q or Q or R. Try that, please. Bring the truth table out in full, right? Right. When you're building it, please remember that you have to incorporate everything, right? So you have your 3 variables. Then after you do your 3 variables, right? You have your P and Q. You have your Q or R, and then you combine them. P and Q or Q or R. Somebody knock that? Okay. Well, 1 minute. All right, let's see what happened here. Let's see what happened here, right? So because it's, what does man do here, right? So here it's true, 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 true. False, 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 false. False, false, true, true. And here's true, false, true, false. Right? And the P and Q. Well, could we have a late class next week, like about same time? But still, I want to have a class. I don't want to end up in the evening, like normal time, half past 5, 6. We can do that. Right? I'll message you, right? All right. P and Q. P and Q is what? True, true, false, 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 false. That's okay? And the Q or R, that'll be true, 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 false, true, 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 false. And now we want to OR both of them. So that's true, 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 false, true, 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 false. That's okay? So it appears that these two are logically equivalent. Yeah? They didn't ask us what. Right? Any issues online? Ranju, are you okay with this? Tamia?
So explain back how you get the Q and the V and the R.
The Q or R, all I did is I look at this. Q. I look at Q or R and I use the or. True or true is true. Right? So you have to go back to the disjunction statement and use that.
Okay, sir.
All right. Nice. Let's continue. So we learned to develop truth tables. We learned to check for logical equivalence, right? Let's also, oh wait, no, we didn't do conditional. So we did negation, we did conjunction, disjunction. So the next one, the next connectivity that we're going to use is conditional. That's okay? So once you see the arrow, it means conditional, right? So the rules are true implies true, that's true. True implies false, that's false. False implies true, that's true. False implies false is true. So basically, they are all true except when true implies false. Okay? So once you see true implies false, then that's a false statement. Everything else is true. Okay, so as you go along, you should make those little summaries and make sure you know what you did, right? So you did negation, conjunction, disjunction, and now conditional. Okay, so the main thing you have to learn in conditional is right here. True implies false. Right, so if you look here, that arrow means implies, right? So if you want to connect Thomas Smart and he does well in exams, you want to connect it via words with a symbol. You say Thomas Smart implies he does well in exams. Okay? You okay with that? So once you're taking up this symbol here, the arrow, right? The arrow can be represented by the word implies. Okay? Here's a quick truth table. Here's a quick truth table on P conditional negation of Q. Right? So if you look at P and negation of Q, what you see here? True implies false is what? False, correct? True implies true as. False implies false as. False implies true as. Okay with that? Okay, so you have to learn all these things, right? You have to learn all these connectivities and negation as well. Easy, right? Right, we'll do a biconditional. All right, yeah. Let's take a look at biconditional. Biconditional means what? Biconditional implies that when the statements when the truth values are the same, right? The statement is true. Anybody remember what gate is this? No. Huh? No. What do the unit people might know? What gate is that?
Safila X or X no.
X no. Very good. You all didn't do that at 1.5. The X no gate. X no. Right? Biconditional is 2 arrows, right? Back to back arrows, right? Check out these a little bit. Are they good? Huh? No, I'm touch it. No, I do anything, you know, I was going to put it on, oh, it's not working. I went the wrong remote. Oh, yeah, it's not working. Sorry, I bring the wrong one. Sorry, then. I bring the wrong one. Right, biconditional. You're okay with that? Add that to your list. Quickly, as a quick revision, tell me all Shivish that we just learned. Yeah, negation, conjunction. I asked you, disjunction.
Conditional.
Huh? You didn't get conjunction? No, those are definitions. These are the 5 truth tables that we have learned. Right? Okay, nice. So nice and easy. Nice little rules you have to learn. Right? Next thing we can try past paper. Right, before we do that, right, we have to learn 3 more definitions. Okay, last 3, real easy. If I give you a conditional statement, P implies Q, right? If I give you a conditional statement, P implies Q, then the converse of that statement, you just flip it around. So you flip around the Q and the P. If I ask you what's the inverse of this statement here, you just negate the P and Q. And if I say, well, what's the contrapositive of this statement here, you flip it around and negate them. Okay? You flip it around and negate them. Just copy that down quickly. I want to give you an example. A next example. Right? Let's take the negation of P implies Q and find the converse, inverse, and contrapositive. Converse, inverse, and the contrapositive of this statement here. Negation of P implies Q. Right, somebody else knew was supposed to start today. I think it was you. What's school again? That was a girl. Can't remember now. Right, we'll study hard stuff the following week, right? Nothing hard as it. The hardest thing that you'll do, you want proofs. When I do proof by induction and all those proofs, that's the hardest thing. Right, we used to do in ADMAS, we used to do something called direct proofs, left hand side equal to right hand side. Now we have to prove by something called induction. So we have to follow some steps to prove something. A little more work. Sorry? No. 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 Right, converse, false. What's the converse of the negation of P implied Q?
It will be QR and the P with the little sign of negation.
Right, so that will be Q implies the negation of P. Right? Right, the next holes now. What's the inverse? Right, P implies not Q. And last one. Last one is what? Negation of Q implies P. So you flip it around and you negate that. Okay? Or you can just negate the converse, or you can flip the inverse. Okay? Okay, so those are some of the rules that we need to learn. Let me see if we can squeeze in a paper. The conjure positive. Yeah, I take the Q and I bring it across and I negate it. Right, let's try one little past paper.
So a paper 3 in pure maths, would it be hard?
No, you're not doing paper 3, you're doing the SB.
No, so I write in an extra subject outside this pure maths.
Right, no, but you could do the pure maths through our school and you will get to do the SBA. Because yes, to answer your question, yes, paper 3 hard.
So how I could do the SBA from your school?
You just sign up to the office and they will handle it.
Oh, okay.
All right, let's give 2018 a quick little try. Try this fast, Olia. Ready? Shavish, you have a question to do. Hurry up.
So one more question.
Come on, let's finish up this.
Was I diving around someone?
Right, apply this once. Wait, why me? I come face to face to discuss. Apply. Yeah, the unit to apply. I'm visiting to apply. Some subjects here. Because it's a small group. So I'll have 2 in one class and 4 in the next class. Huh? Physics for sure. Applied maths possible. Bio. Electronics and it. Right, let's see what we got here. Ready? Right, let's start with the negation of P, F, true, F, true. That's okay? And then we want P or Q. P or Q, so that'll be true, false. And now we're going to negate all of that. False, true. Right? How are we getting this now? We're looking at P and Q. Okay? So using conjunction. False and false, that's false. False and true is false. True and false is false. True and true is true. These 2 columns are identical. So you're telling them that the truth values for the columns are the same. Therefore, they are logically equivalent. You all have that? You have to have that statement. Huh? The truth values are the same. Therefore, they are logically equivalent. Right? Next week, I'll try to have a class late in the evening about 5:30, right? Now online only. I'll message you. If it don't work out, well, I'll let you know. Most likely it should work out. Huh? Now when we go. Huh? All right, online. So that's it.
So wait, I have a question. You listening?
That's not Stacey.